All right, so for our next example, I will also mention for the last example, I'm going to refrain from doing the problem on the next page as it's a little more complicated and I don't need you worrying about it. But for this one, notice we do have the polynomials in their full form, so we will need to factor. Luckily, these don't take a whole lot of work to factor. So we'll start with the x squared minus 9, because if we want to know where that equals 0, we can just use difference of squares to factor that out. And so we're going to get x plus 3 equals 0 and x minus 3 equals 0. So we get negative 3 and positive 3. Both of those coming from single factors. So I'll go ahead and just throw in here multiplicity of 1. And even while we're at it, since we know we're dealing with the x-intercepts here, which I should label, since these are the x-intercepts we're dealing with, we're going to go ahead and mention that these are both points where our graph would cross. So we know our graph crosses at both of these, which again, as far as this problem's concerned, we're not really graphing, so we want to know that that means it's going to change sign. That's really the important idea. There's our x-intercepts. Let's look now at our vertical asymptotes. It's going to come from our denominator, x cubed minus x squared minus x plus 1 equals 0. Being a 4 term, we will try grouping. First 2 terms, plus second 2. Factor out a GCF there. Factor out a negative sign there. That gets us what we need. We get those matching. So we factor out that x minus 1 as a GCF. Leftover of x squared and a minus 1 will be the leftovers, which will factor even further. So bring down the x minus 1, and then that will factor to the difference of squares, x plus 1, x minus 1. And then we notice we actually have 2 factors of x minus 1. So x minus 1 squared and x plus 1. So for those vertical asymptotes, we're going to have x minus 1 equals 0, giving us a 1, and x plus 1 equals 0, giving us a negative 1. For these asymptotes, the multiplicities are 2 and 1, multiplicity 2, multiplicity 1. And again, the even multiplicity would mean same infinities. So for us, what's important is it's the same sign. For this one, for an odd multiplicity, we're going to have the change of sign. It looks like my light is dying. That's not good. All right, so that's our information about our intercepts and our asymptotes. Now on to our graph. Putting those values of negative 3, positive 1, and negative 1 in order. Negative 3, negative 1, 1, and positive 3. And then, and then again, with this number line, we don't have end behavior for this kind of function. So we need just a single point. Again, I'm going to pick 0 because it's convenient and it falls there in between the negative 1 and positive 1. And so figuring out what that is, going back up to our original polynomial and plugging in 0, I'm just going to point out all your x terms are going to go away very quickly and easily. That is just a negative 9. That is just a positive 1. So plugging in 0 here, giving me negative 9 over a 1, or in other words, negative 9. Again, all that matters is that you find that sign. I'm sorry, I keep not showing the work. Negative 9 over 1 being negative 9 being negative, right? Being below 0, telling you that everything in this interval is going to be negative. So that's where we're going to start with that. Also, we want to go through and place the appropriate circles on these values. Going back up to the inequality, that's where this or equal to is important, because again, that or equal to is what tells you you do want to fill in the dots on these two x-intercepts. If that weren't there, these would be open circles, and the asymptotes are always open circles. But in this case, we want to include the values at negative 3 and positive 3. So I will put a closing circle there and there, but always for asymptotes, open circles. All right, so now going back from our one sign we know, one way or the other way, if we go to the right, hitting this x equals 1, which was our vertical asymptote, that had a multiplicity of 2. So it's going to be the same sign. It's the idea of the same infinity. In fact, I'm going to get rid of that because I put the negatives below. So we're down here, we're negative in this interval. And then on the other side of this asymptote, we're also negative. We're doing that same infinity, same sign there, keeping it the same. Then we're hitting 3, which was an intercept with multiplicity 1, where it crosses and changes. So we're crossing and changing from negative to positive over there. So from negative, same sign negative, changing positive. Going to the left, starting at negative, hitting our negative 1, which is multiplicity 1, so it's changing from negative to positive. And then from positive, hitting negative 3 also having multiplicity 1, so it's changing from positive, crossing over to negative. So negative to positive to negative to negative to positive is our signs. And now that we have that, we go back up and look at the inequality being less than or equal to 0. So we want all the negatives and the or equal to's, the points where it's on the line. So starting at negative infinity over here, because it is negative coming from the left, getting to negative 3, stopping and including it for the or equal to, getting over to this point, negative 1, but not including it, open circle, up until we get to the 1. Now here we got to stop, not include the 1, hop over, but it's negative on the other side. So start up again there. This is an instance where here it's negative, but there that's not included. So you're just hopping over the 1, going on to 3, which again, being a point and that being the or equal to, is included. So we throw a bracket on there, and there's our final answer.